Hello, let's continue a little bit more on this meshing. I've kept the geometry from a previous tutorial and I want to show you some more functionalities here. To be honest, there are so many ways to do this and I'm not sure if I necessarily need to do all these things very often, but it's nice to see. So let's take a look at, for example, if I have this basic setup as I have now, I can just make it measured, and you've seen this before to be quite a straightforward mesh. Well, maybe I want a very simple mesh in here because I have a rectangular and I would like to say something about that. I want it to be meshed separately, so maybe I want to put in a quadrature mesh there. So let me try to do that. I keep this on mesh level here and then I say I want to have a free quadrature there. Then I say, okay, let me look here now. I have to select the domain in which I'm going to put those elements. So let me do that. And it says remaining. I don't know what it means. I would like to pick a domain. I say it will be on this domain. And there is in fact a function. I don't know exactly why it is like this, but it seems like the free quads should be done before the triangles. So I just put it up there just to make sure that it has its right position. And then you see here, this thing here is like it likes to measure the whole thing, but that's not what we can do, because if I have that mesh here and I want to put a triangular mesh on the rest of the domain, I have to simply choose that domain. So that must be this domain here. So this domain, I have to take away that domain. I don't know what came up there. So now I have, for the quadrature, focuses on that part, and the triangular ones are there. Let's try to mesh. Oh yeah, you see here it came up like a very nice regular mesh here in the middle point here, and it became a triangular mesh there. I would say it's not very much I would like to play with here, more than the fact that you see two meshes. What we could have done, we could have taken away this free quadrature again, and said let's try something else. I take away that quadrature, and then I introduce what's called a mapped mesh here. And I should also, should also put that on top of the triangular ones. I should double check where is it. It's going to be, it should be in that domain. I hope that the triangular one is okay now. Yeah, you see the triangular one is on this green domain here, so the mapped ones are there. So the mapped ones are simply rolled out as a very regular mesh. It will always be built like that, very regular. So it will always follow things that are inside. If I had a other mesh, the quadrature mesh, it may be more messy inside here, but this will always be very regular. I can go up here in size. I can pick the finer one, extremely fine. I can just build it and see how it works. Comes out fine. Let's go down again and make a normal mesh again here. So let's see. That's the one. If I want now to influence the line along those straight elements here, maybe I should try to do that. Then I say I have I have this one here, and I want to make a size function there. Is it possible? Yes, it is. I want to try this one. Then I want to push. Is it possible to actually influence on the boundary? No, it's not. I can't do that. I have to follow the outer one. But let's try. We can, for the whole domain, we can find an extra mesh here. We can't do it for on the boundaries. We can't specify on the boundaries. So let's look what happens now. Oh yeah. So I have this defined regular mesh, but I can do it on the surface. So I can actually make a fine mesh in there looking at that specific surface. I can do it by changing the size. So I can go in here and say, well, I want those elements to be far less than that. I want them to be very small, and I say build all. It's a huge number of meshes here, but they are generated extremely fast, simply because they are so simple. See here how fast they became quite good. We can go in very regular mesh, and also auto mesh will follow. Maybe that's a thing we need in some situations. So now you saw a little bit of the use of this mapped mesh and the free quads, and we can use the free quads and the free triangulars one at the same problem. It could be fun to use that and see how it comes out, influencing the results. The last thing I would like to say something about is the boundary layers. The edge thing here, I don't have any experience with that, so I'll wait with that. But any boundary layers are very important. So let's go back here and say, well, I will cancel the one we have now. So we are back to a very simple free triangular mesh. You can generate it again. It looks like that, as you've seen before. Now I want to talk about a more specific meshing that is actually very interesting later on in this course. You see, you learned in your physics course that the current may get a skin effect when you have AC and time domain changes in the field, magnetic field. So let's say this was a case in which we have induced currents and skid effects. Then if that happened in this conductor here, so if this was a conductor and the current is flowing in and out, you should expect this to be actually quite a tricky analysis, because the current will flow in here, it will go in at the surface, and practically no current will flow in the center part. That is actually a challenge for the finite element meshing, because we need the mesh to follow the solution. And that is possible to do with these boundary layers. So let's try the boundary layers. I introduce a boundary layer here, as I simply say here, boundary layer. Maybe I have to do it here. No. Boundary layer comes here. So in that case, first I have to define the domain in which I'm going to get this boundary layer effect, and I want to use this one here as the test object. So that is my conductor now, and I want it to be small elements on the surface around here and large elements in the center part. So what do? I have now chosen not any parameters. I've simply picked the inner or the total domain. But here you see there is a boundary definition inside here, because I have to tell the software on which surfaces do I really have that skin effect. So in this case I actually have to change, or not change, but I have to select the surfaces, which is this one here, this one, and this one. So that's where I'm going to, inside that domain there will be elements generated, and they will have a variation towards that line. I think I should simply try now and see what happens. See here, automatically I got a finer element sizing inside here. Maybe I have to make maybe I should try to make a focus on the size also there. Maybe I should pick a much higher finite elements density here. So then I go in here again, I'll choose the domain, and I will choose that domain, and I say it should be quite extra fine elements there. So let's try now. See, I put the size function under there, to make that domain in particular small with elements, and then the boundary function, the boundary layer mechanism comes afterwards. Let's try. So still I have small elements here now, which maybe are too small. So maybe I should make that a bit larger. Maybe it could be like that. And you can see here then, on the perimeter side here, for this skin effect oriented meshing, I can go in here and look a little bit more in detail. So I'll see what happens. And now I see I have a number of boundary layers. I call 8 here. So there's 1, 2, 3, 4, 5, 6, 7, 8. And they have a boundary stretching factor to be 1.2. I think it means that I'm not sure what it means. So let's try to put this to make this 2. See what happens. Let's try and then say, oh yes, no, this became very much thinner. This is bigger. Maybe that was a bit too much. So maybe I should go back to, let's say we can pick 1.4. See how that goes. Oh, I was a bit quick there. Like that. So then I'll do a build all again. See, they stretch out quite well. Maybe I should go a bit out for you to see. So this is going out. But this thickness adjustment factor, maybe we should try that one too. What happens with that? I go from 1 to 2. Nothing happened. I don't know what was there. And then it's thickness of the first layer. That's automatic. I could choose a manual one. But I don't see what happens with this factor here. So let's go back to 1 and see what we can see something now. It's something in here that happens. So it looks like, let's say again, if we make this to be 3 then. What happens then? It should happen inside here. Look there. Yeah, not very much happened. So you see what happens is that the 8 first elements are actually quad elements, and then a part is then freely meshed by a quadrature. So here the program is actually using quad elements because they know by experience that it's smart to have that kind of element shape, since the solution varies in that way. Okay, I think I'll stop there. We have been through 3 triangulars, 3 quads, mapping, boundary layers. Yes, and I think that's fine. Thank you very much for this time.